Hello and welcome. In this video, some background information about Python is discussed. I will provide details about the software that we will be using in this course, and I will highlight the differences between the two interfaces that you will be interacting with. I will also briefly explain what Python packages are about as it relates to this course, and I will demonstrate some selected features related to Python, such as documentation, commenting, and print functions. In this course, you will first learn about the basics of programming in Python to get prepared for the analytics side. It is critical to make sure that you understand the programming basics, otherwise you will have a very difficult time moving forward to the more advanced code. In addition to the lectures and video demonstrations in this course, you need to practice Python on your own and as much as possible. In order to really understand the programming logic and syntax, try interacting with simple, quick exercises every day. Websites such as realpython.com and w3schools.com are very informative and have interactive exercises that you can work with. I highly encourage you visit these websites as part of your learning experience. For those of you who have taken a programming course in the past, you will notice in this course that some of the programming concepts are accelerated. There's simply not enough time in this course to cover all the concepts in great detail, but we will cover the necessities in preparation for the analytics component. The more you practice, the more likely you'll start enjoying the programming experience. Do know that making coding errors is part of the programming experience, and do not let this intimidate or discourage you. The more errors you are faced with as you learn, the better you are able to tackle this as any issues arise later on. So what is Python? Python is considered to be an interpreted high-level general-purpose programming language. Comparable languages would be Java, C, C++, and so on. Low-level languages are more complicated to code and difficult to interpret. It could be thought of as code that is translated into binary format for computer machines to understand. Since Python is an interpreted language, the high-level code is translated into low-level code for system processing. Python is used for things such as data analytics, application development, and the web. We'll be focusing on the data science aspect in this course. What's neat about Python is its coding structure. It uses indentation, making it a little different from other programming languages that use semicolons and commas. People prefer coding in Python because of its easy-to-read syntax and the amount of code required to achieve the same objective. You can see that in this slide, there's a syntax comparison between Java and Python. Python is on the right-hand side. You can see how simple it is to do a print function in comparison to Java. So in this course, we will be using a couple of Python software applications. All the software will come from a distribution software package called Anaconda. Within Anaconda, there will be several software applications, but we will only focus on Spyder and Jupyter notebooks for this course. These are considered to be what we call integrated development environments, or for short, IDE. You want to download and install the free version of Anaconda as soon as possible from their website. To download Anaconda, go to www.anaconda.com/download. Make sure to select the individual edition, which is for free. Then towards the bottom of the page, select the appropriate installer file that best fits your computer specifications. Once the file is downloaded, locate the file and go through the installation process. It's as simple as clicking next or clicking the next button until everything is installed. At the end, you should get a confirmation screen. Once Anaconda is installed, you can access Spyder or Jupyter Notebook through clicking on the Anaconda application file, or you could search for the specific software you would like using the Windows search bar. In this slide, I provided snapshots of the interface for both software applications. On the left-hand side, the interface contains an editor as well as an interactive console. The interactive console allows you to examine code and receive feedback instantaneously. The editor is used to write and store code. You can save and execute your code inside the editor using the shortcut buttons on the top portion of the interface. But it will also be a good idea to get familiar with the keyboard shortcuts, which could be found under the Help section on the application. On the right-hand side, a Jupyter Notebook file uses the web browser as its interface. The Python code is entered inside the cell. There's no interactive console, but one could be opened up separately to test out your code. One advantage with Jupyter Notebook is the graphical representation capabilities that it has. If you have some HTML experience, you can make your notebook file look really neat. In my personal opinion, Spider is a great application to use when learning how to code. It is also really good to use when it comes down to developing lengthy code. Eventually, once you get used to both, it becomes a matter of personal preference. Both IDEs are capable of running Python code and providing the results without having to open up another software to see the result, as with some other IDEs. You will want to familiarize yourself with both of these applications, start navigating through the tabs and get a feel for them. A video demonstration will be provided that will explain some of the baseline information to note. As you learn the Python language, you will also get familiar with several Python packages. Packages contain modules which are already developed programming files for specific tasks. Packages simplify programming code since a lot of the complex coding has already been developed in these packages. Depending on what it is that you're trying to accomplish, there are specialized packages that may be used. For example, if I want to work on data visualizations, then I would use the package called matplotlib. Just to give you a quick idea of these packages and how they work, we can get the arithmetic mean using pure Python without any sort of package involved. It will require a little bit more coding to do, but we're able to do it unless we want to use the NumPy package. Within the NumPy package, there are different functions that you could call, and it will be able to automatically get you the arithmetic mean. This is similar to an Excel function using the = average to be able to get that specific descriptive statistic. To illustrate how to compute the mean of temperatures is shown here. Example A uses Python without any predefined package to obtain the mean of temperatures. Example B uses Python but makes use of the NumPy package. NumPy is short for numerical Python. It's great to use NumPy when dealing with vectors or numerical arrays. When comparing example A to example B, it is quite clear that example B uses less code and thus requiring less time to get a result. As you are in the beginning stages of learning Python, it will be valuable to understand the underlying code or the algorithm that is used to achieve a certain task. Notice on line 16 that there is an import statement for NumPy. All third-party packages will need to be imported in order to use their functions. More about this later. It is very important to understand that learning programming requires that you frequently review Python documentation. There's an abundance of Python documentation found online. Programming errors are called bugs, and it will take a considerable amount of time debugging errors. You will need to get comfortable with making errors as you are developing programs or testing out snippets of code. With any error that you are unfamiliar with, do an internet search, modify your code, and test it out again. This will be an iterative process until you get it down correctly. This is all part of programming. If you conduct an internet search on a specific error message, oftentimes one of the first search results will come from the python.org website. I believe it's, yes, python.org website. If you don't find that information to be useful, look over other results in the search. Viewing different explanations will help. Again, it will take a lot of time doing this, and do not get discouraged. There is also some integrated documentation within the software applications themselves. Using the help function, for example, could be useful. Here's an example of using the help function where the value is print. Print itself is a function, so here the help function is being used to get information about the print function. The output is quite detailed. Not every piece of information may be needed. It all depends on what you're looking for. In this example, you can see that the print function can hold other arguments besides value, such as SEP or END. SEP stands for separator, and END stands for end on how you would like to end the print function. These are detailed all within the documentation. Let's take a look at a print statement. The print function returns a value inside the parentheses. How to handle print statements ultimately depends on the value type. Python has many different types of values in objects. If you have taken a database class before, this is referred to as a data type. In this first example, the value hello is stated two different ways, one with single quotes and one without single quotes. The print statement that contains hello without quotes will result in an error, and that is because the print statement is assuming that the value hello is a defined variable, which has not been defined in this example. Looking at a different example, the print statement that contains 433 with single quotes is still considered to be a string value. Anything within a single quote or single quotes is considered to be a string value. However, the print function of 433 without quotes will print 433 with the assumption that the value is an integer. Knowledge on value types is critical and will guide you on how to use certain functions. This sounds a little complicated and confusing, but we will be doing exercises to make sure things are clear. Python allows for different ways to comment. Commenting is used for documentation purposes, and it is good practice to use comments to help explain pieces of your developed code. You will see me use comments a lot for instructions on problem solving. In this illustration, line 1 uses triple double quotes, whereas in line 4 it uses triple single quotes. These two particular methods allow for multi-line commenting. Anything could be entered between these triple quotes, and they're considered comments and will not affect your code when it is executed. Line 7 uses the hashtag symbol and is a one-liner commenting method. When lines 1 through 8 are executed, the output results to a list of words from 3 print statements, as shown underneath line 8. Only the code in lines 2, 5, and 8 were returned, while the comments were ignored. Programming is about systems thinking. And as you are interacting with code, you should be asking yourself why certain things work a particular way. Much, if not all, the coding syntax requires an input or inputs that will be processed for an output, which is the result. In systems thinking, there is nothing to process unless there are inputs involved. An example that I have here on this slide shows you a simple print statement using Python. The print function is the process, but it will require an input. In this case, it's the word hello in quotes. The output is a result of the print statement, which is the displayed word hello without quotes. Now that you have some background knowledge on Python, the different software applications that we'll be using, make sure that you download it, install it, and mess around with the different IDEs. You have enough syntax to play around with. Try a print function, try some commenting, use the help functions, and so on.